being a graduated math student, like, is there more complicated math specifically?
So I can try to answer what what you're used to and how that gets
Yeah.
complicated, but also I want to point out that people often say that math is like it builds upon itself and it's like this linear progression. That's totally not true. Okay, like for a math major, like you'll probably know a lot of math majors, but after you take like the calculuses and then like a, a proof introduction class, the calculuses are mainly to give you, some sort of mathematical maturity. But after you learn how to write proofs, it's just a branching. You get topology,
True.
abstract algebra, this, that, and the other thing, and you can take one and have no idea about the other, and it doesn't matter. Like they don't. I mean, knowing one will help the other, but it's not always a progression of complication. Now, when it comes to calculus, y'all are in multivariable calculus, so let me think. Functions can get a lot more complex in the sense that they don't need to be functions of, just real numbers or sets of real numbers.
Functionals, right?
And yeah, and calculus in general. So calculus can be done, or an abstraction of calculus can be done on a lot of different types of mathematical structures. They're called manifolds. So R2, the real number, the real plane would be an example of a manifold, but if you can think about the surface of a sphere, also known as a sphere. A sphere is only the surface, but that's a manifold that you can do similar things on. So it's not always about just complicating things. And in fact, to some degree, it's about simplifying things. And whenever you abstract something, you're really kind of simplifying it in a certain sense.
I guess that is the other way. I guess that is a nice way to look at it. Like, it's not really complicating it. In fact, so by going into the more abstract, you're actually simplifying it. That's a
Yeah, I
nice way
think
to think
so.
about it.
Yeah. So another thing is that some people might think of things that are abstract as not having any application, but that's not true, because whenever you make something abstract, what you're doing is you're kind of removing the superficial details from it. Okay? So when you do that and you have this abstract creature, it's like, oh, what is this even talking about? Well, it's talking about whatever is modeled by that situation. I always think of, y'all know Lex Friedman?
Of
Yeah,
course.
yeah.
Okay, so I always think of a conversation between Grant, Three Blue One Brown,
Yeah.
and Lex Friedman, where they're talking about higher dimensions. And Lex Friedman, great guy, but he seems to be under the impression that dimension has to mean spatial dimension. And in this conversation with Grant, so he mentions higher dimensions maybe being this esoteric thing, and Grant's like, no, these can be highly applicable. And he's like, it's a common misconception that higher dimensional mathematical structures are only applicable to a universe that's that many dimensional. But that's not true, because a dimension, the math does not care what the dimensions represent. So you could think of there are 4 macronutrients: protein, carbs, fat, and alcohol. And you could make a vector space out of those 4 things. That's a 4-dimensional vector space. And a food is a vector, a 4-dimensional vector, and a diet is a group of vectors. And if you want a calorie count, that's a linear transformation into the real numbers. Like the math does not care what these things are representing. So when things are abstract, it means there are a lot of applications. Anything that can be described by this mathematical structure, it can be applied there. The math does not care when it's abstracted, if that makes sense.
Yeah, definitely. And my physicist brain, when you, like, the example that you went into was great, but I was thinking of like you could have like a vector where it's like xyz, the position, and then the velocity xyz, and then you have like a 6-dimensional vector, but it's still describing something in 3 dimensions, but you just use these.
Right.
Yeah,
there are 3 spatial dimensions, but
yeah.
A dimension in the sense that the mathematics is concerned is basically just like a continuum of values.
Yeah.
Like Pokemon have attack, defense, special attack, special defense, and speed. So Pokemon are 5-dimensional. Those are 5 independent. I think that's all of their stats. But yeah, yeah. The math doesn't care if the dimension represents spatial dimensions or the amount of protein in a food. It doesn't care. So when you abstract it, it no longer cares about the superficial details.
Mm-hmm.
So in that sense, abstracting things it makes it more applicable to more things because all the superficial details have been, surgically removed.
Interesting way to think about it. Damn, that's a really an interesting way to think about it. So like, so continuing on this journey of your college experience, after your whole physics to double major to pure math change that you did over there, what after you graduated? What was the situation then?
Um,
What was next for
uh,
John?
I worked a couple jobs and ended up going to grad school for a long time. And then I put that on hold recently. Grad school's tough to stay in for a long time. You're ready to get out eventually.
Mm-hmm.
So yeah,
Is grad school a
and
lot of like studying as well, or is it mainly
yeah,
just as they say, just writing papers and stuff? Like, what's the?
no, it's a lot of studying. The material gets way harder really fast. Like
Wow.
the first year of grad school was like okay, then it started to pick up, and it started to pick up even more. And yeah, it gets pretty difficult.
And did you go to grad school just for math?
Yeah.
Okay, cool.
Any advice
Cool.
for, I don't know, just grad school goers, like soon, if anyone is graduating this year, maybe next year from college, any advice to them going into grad
Um.
school?
Yeah, I would say make solving problems and studying kind of a social event with your other grad students because it's more fun that way if you're like hashing out problems with each other,
Mm-hmm.
sitting around, because math especially can be a very social thing. There's a lot of inside jokes and all this stuff
Yeah.
happening with math, and there's funny stuff. I mean, I'm sure y'all are aware of that.
Of course.
Like yeah. So I think it's a fun it's fun whenever you have other people involved with you.
Mm-hmm.
Mm-hmm.